Hello friends, myself Dr. Nandakumar Raubali from College of Engineering Ambajogai is going to deal with fluid mechanics for second year BTech Mechanical Engineering, the syllabus prescribed by Dr. Baba Saheb Ambedkar Technological University, Lunere. So this is our first lecture. So in previous introductory lecture, we have seen about the syllabus prescribed by Dr. Baba Saheb Ambedkar Technological University, Lunere. Now today we are going to discuss about what is a fluid and what is the meaning of fluid mechanics. Then introduction to the properties of fluid, dynamic viscosity, kinematic viscosity, then we will see what is a fluid. So very first, a fluid is anything that is capable to flow. Generally the air and any liquid are going to flow. Therefore the liquid and the gaseous substances are referred as the fluid. So anything capable to flow is known as a fluid. For example, we have a gas or a liquid is known as a fluid. So fluid includes gas as well as uh, liquid. Both the things are included in this fluid. Then what is the fluid mechanics? So fluid mechanics is the branch of science which deals with the behavior of fluid. Either the fluids are at rest or in motion. So if the study is carried out in this branch of science where the behavior of fluid is studied, it can be a gas or it can be a liquid, and it may be stationary or it may be in motion. So the fluid mechanics is the branch of science which deals with the behavior of fluids which are at rest or in motion. So we study in this fluid mechanics. Then we see specific branch of this fluid mechanics as fluid statics. So what is fluid statics? So fluid statics is nothing but study of fluid which are at a rest. The fluids which are at rest and the study carried out for the fluids at rest, say for example water stored in the reservoir in a tank. So the study about the fluids which are stored is included in fluid statics. But fluid kinematics is also the study of fluid, but fluids in motion, but without considering the pressure forces acting on it. So fluid kinematics is again fluid mechanics where we are going to study fluid in motion without considering the pressure forces acting over it. Then there is a third type, that is we call as a fluid dynamics, where again we study fluid in motion, and there we are going to consider the pressure forces acting on that fluid. So we can see here fluid dynamics is the study of fluid in motion considering pressure forces. So here we are going to consider pressure forces. Next we are going to see introduction to fluid properties. So which properties we are going to study today, that we see here: density or mass density of a fluid, then weight density, specific volume of liquid or a fluid, then specific gravity, and dynamic viscosity, or simply it is known as a viscosity. And then we are going to study kinematic viscosity and Newton's law of viscosity. So now very first, what this density is. Density is nothing but it is defined as the ratio of mass of fluid to its volume. So now the ratio of mass of the fluid to its volume is known as a density. Sometimes it is known as a mass density. So say for example, in some container we have some liquid. So this liquid is having some mass m, and if we know its volume v, so mass divided by volume m divided by v, is nothing but mass density. So it is defined as the ratio of mass of fluid to its volume, or it is nothing but mass per unit volume of fluid, which is called as a density. Generally it is represented by rho. Rho is its representation. Then this is written in the mathematical form: mass density is equal to mass of fluid, which is in kg, divided by volume of fluid in meter cube. So kg per meter cube is the unit for mass density. Now this is first parameter, mass density, where we are going to study the ratio of mass of fluid to volume. So if we know mass of fluid, it may be a gas or liquid, and volume of that fluid is known, then we can find out mass density. So sometimes this is simply known as density or mass density. Density refers to mass density. Next, coming to specific weight or weight density. So just like mass density or density, weight density is referred as sometimes specific weight. So this is represented by small w or omega. So it is nothing but the ratio of weight of the fluid to its volume. So it is the ratio of weight of the fluid to its volume. So we can say it is defined as the ratio of weight of fluid to its volume, or it is nothing but weight per unit volume of fluid is called as a weight density. So if there is certain fluid in a container, and if we know weight of this W, and if we know volume W divided by V, which is known as a weight density. So weight is generally in SI system is given in Newton, and volume is given in meter cube. So this is given in the form, mathematical form: weight density is equal to weight of the fluid to volume. So weight is again the product. Weight is nothing but product of mass into acceleration due to gravity. So that we see afterwards. So very first, weight density is weight of fluid divided by volume of fluid, that is in Newton per meter cube. We get weight density, which is represented by small w or omega. Then writing this weight of fluid as mass of fluid into acceleration due to gravity. So we can rewrite this as weight density is equal to mass of fluid into acceleration due to gravity divided by volume of fluid. So this weight of fluid is replaced by mass into acceleration due to gravity. So this acceleration due to gravity is represented by small g. Therefore, rewriting this equation, weight density is equal to mass of fluid into g divided by volume of fluid. But we know that mass of fluid to the volume of fluid is nothing but mass density, which is represented by rho. That is, rho is equal to m divided by v. So replacing this mass of fluid to the volume of fluid by rho, we get weight density is equal to mass density into acceleration due to gravity. So now coming to this specific volume. Specific volume is reciprocal of mass density. It is the volume occupied by unit mass of fluid. So it is defined as the ratio of volume of fluid to its mass, or it is defined as volume occupied by unit mass of fluid is called specific volume. Say for example, 1 kg of gas, if we store into the container in a cylinder, then this 1 kg is going to occupy certain volume. We know volume of this container. So volume divided by mass, V divided by M, is nothing but the specific volume. So this specific volume is represented by small v, that is volume of fluid to mass of fluid, that is the unit is meter cube per kg. So this is nothing but the specific volume of a fluid. So this specific volume can be again rewritten. So this volume of fluid, which is in the numerator, if we transfer it into the denominator of denominator, then this comes into the denominator. Therefore, rewriting this equation, mass of fluid is already in denominator, but this volume of fluid, which is in the numerator, that comes into the denominator of denominator. Then this term already, which we have defined as mass of fluid divided by volume of fluid, which is known as rho. So specific volume can be written as V is equal to 1 divided by rho. As already I told you, the specific volume is a reciprocal of mass density. So we can say specific volume small v is equal to 1 by rho, or that is in meter cube per kg. 1 by rho means 1 divided by mass density. So it is the reciprocal of mass density, vice versa. Then specific gravity. What is specific gravity? Again, this specific gravity is defined as the ratio of density of a fluid, density or weight density of fluid, to the density or weight density of a standard fluid. We can define it like this: the ratio of weight density or of fluid to weight density or density of a standard fluid. What is standard fluid? So for liquids, water is taken as a standard fluid, and for gaseous, air is taken as a standard fluid. So here we can say water is taken as a standard fluid for liquids and air is taken standard fluid for gases. Then this specific gravity mathematically is written as for liquid, specifically for liquid, specific gravity for liquid, yes, it is represented by S. So weight density or density of liquid divided by weight density or density of water. So when this is liquid, definitely here it will be liquid, and in denominator it will be water. So if this is liquid, then here in denominator there must be water. If this is weight density of liquid in the numerator, then weight density of water in denominator. If there is a mass density in the numerator, then in denominator there must be mass density of water. So here, so what is in the numerator, corresponding to that we have to take the values in denominator. If in numerator there is weight density, then weight density of liquid, in denominator weight density of water. If there is mass density of liquid in numerator, then mass density of water in denominator. So here for gases, again it is defined as the specific gravity of gases is defined as, again, weight density of gas to the weight density of standard fluid is air. So again here in the numerator there is weight density of gas, then in denominator there must be weight density of air. If in the numerator there is a mass density of gas, then in denominator there must be mass density of air. So this is how the specific gravity or relative density is defined. So now from this specific gravity or relative density, we can find out density or weight density of the liquid. How we can find it, that we see. So for example, this is the equation for specific gravity for liquid. In numerator there is weight density or density of liquid, and in denominator weight density or density of water. So transferring this term which is in the denominator on left hand side, it will come into the multiplication on left hand side. So weight density or density of liquid is equal to specific gravity of liquid into density or density of water. So just this term which is on left hand side is multiplied by denominator, we get the term which is in the numerator. So rewriting this equation as weight density or density of liquid is equal to specific gravity of liquid into weight density or density of water. So here weight density of liquid, so this numerator is equal to specific gravity of liquid into weight density of water. So this term which is in the denominator is transferred on left hand side and multiplied. Again, this can be written as weight density of water is nothing but a mass density of water into acceleration due to gravity. Weight density is omega is equal to mass density into acceleration due to gravity. Replacing this weight density by rho into g, we can rewrite this equation as weight density of liquid is equal to specific gravity as it is. This weight density is written as rho into g. So rho is nothing but 1000 for water. So rho is a density of water is 1000 kg per meter cube. If we take 1 meter cube of water in a container, and if we take its mass, that will be 1000 kg, and the g is constant of acceleration due to gravity, the value of which is 9.81. So this gives us weight density. So similarly we can find out mass density also. So specific gravity for liquid is nothing but density of liquid to density of water. So this density of water, if we transfer on left hand side, then density of liquid is equal to specific gravity into density of water. So density of liquid is equal to specific gravity of liquid into density of water. So this density of water is known to us, which is 1000. So density of liquid is equal to specific gravity for liquid into 1000, which gives mass density, and this gives us weight density. So here we get weight density, here we get mass density if we know specific gravity of that substance. Then we see one problem. So in this problem we can see here what is given. Given data. Calculate specific weight, density and specific gravity of 1 liter of liquid which weighs 7 Newton. So volume is given. Volume is given as 1 liter and a weight is given as 7 Newton. So 1 liter volume, generally we need volume in meter cube. So convert this 1 liter into meter cube. So in 1 meter cube, 1000 liter of water is there. Therefore, dividing it by 1000, we get 1 divided by 1000 meter cube of water. Liquid. So 1 divided by 1000 meter cube is this volume, or we can rewrite this as 1 into 10 to the power of minus 3 meter cube. So we know weight. So specific weight is nothing but specific weight that is weight density is equal to weight of liquid divided by volume of liquid now weight of liquid is 7 Newton divided by volume is 1 divided by 1000 meter cube. So simplifying this, 7 into 1000, that is 7000 Newton per meter cube. So this is weight density. Now mass density or density is equal to mass of liquid divided by volume of liquid. But we know weight, we don't know mass. So to find out weight or mass, weight is equal to mass into acceleration due to gravity, or mass is equal to weight divided by acceleration due to gravity. Now weight we know that is 7 and g is equal to 9.81. So if we divide this, we'll get 7 divided by 9.81. We get this as 0.713 kg. So unit of mass is kg. So now substituting this value as 0.713 divided by volume is 1 divided by 1000. So this will become 0.713 into 1000, or this can be written as 713 kg per meter cube. So density is rho, we get as 713 kg per meter cube. Then specific gravity, yes, specific gravity is equal to mass density of liquid to the mass density of water, that is standard fluid. So mass density of liquid is 713 kg per meter cube divided by mass density of water is 1000. So this is going to be 0.713. What will be unit? So unit for mass density of liquid is kg per meter cube divided by kg per meter cube. Kg per meter cube, kg per meter cube gets cancelled, and this term specific gravity is a term without unit. So dimensionless term we are going to get. So three things we have obtained. Very first is weight density, which is we have obtained as 7000 Newton per meter cube. And mass density we obtained as 713 kg per meter cube, and specific gravity as 0.713. So this has got no unit. So now coming to the next thing, next aspect, viscosity. So what is this viscosity? When a fluid is flowing through any passage or over a surface, so the resistance is offered by one layer of fluid to the other layer. The resistance offered by one layer of fluid flowing to the adjacent layer is nothing but the viscosity. Now you can define it as it is the resistance offered for movement by one layer to another adjacent layer of the fluid. Say here we will consider one surface over which a fluid is flowing. So when a liquid is flowing over this surface, so the layer which is very close to this surface is going to stick up with this surface. Say first layer is going to stick up with this layer, it is not going to move at all. So this first layer is going to stick up. Then if we move to the second layer, second layer is at some distance, so this is having certain velocity. First layer was having 0 velocity, so this layer is having velocity u1. Again third layer which is again somewhat away from this will have some higher velocity, we say u2. As we move away from this surface, the velocity is going to be higher and higher. That is shown here by velocity profile. Say we have one surface over which the fluid is flowing. So to this surface, the layer which is moving over the surface nearest to the surface is having velocity 0. As we move in the upward direction, the velocity is gradually going to increase. That is shown by this curve. So this is nothing but velocity profile. So as we move away, the layers will have higher and higher velocity. So this is 0 velocity, it has got some velocity u1, this has got velocity u2 and u3, u4 and so on. The velocity is going to increase gradually as we move away from the surface. So when we are very close to the surface, velocity of fluid or liquid flowing over this surface is 0, and as we move away, then velocity is going to change. Now we can see here one thing, that the layer which is considered at a distance y from this surface, so this layer is moving at velocity u. So this layer which is at distance of y from this surface is at distance y is moving at velocity u, and another layer which is again very close to this layer at a distance, small distance dy, is moving at a velocity higher than this first layer. So this is first layer and this is second layer. So first layer is moving at velocity u, whereas second layer is moving at velocity u plus du. So there is a difference between velocity, that is u plus du minus of du. So the difference is u plus of du is the velocity of second layer minus of velocity of first layer is u. So difference, if we cancel this u and u, so du. So this difference in the velocity is in the vertical distance of y. So this is the rate of change of velocity with respect to the distance y is directly proportional to the shear stress. So This is directly proportional to the shear stress, and shear stress is represented by tau, which is directly proportional to du by dy, where du is the velocity difference and dy is the distance, or with respect to distance between the two layers. So if we want to remove this constant of proportionality, this shear stress tau is equal to mu into du by dy, where mu is nothing but coefficient of dynamic viscosity. It is known as a coefficient of dynamic viscosity. Okay, coefficient of dynamic viscosity. Coefficient of viscosity or dynamic viscosity. Now this mu can be written as mu is equal to shear stress divided by du by dy. Shear stress du divided by dy is mu, which is known as the coefficient of viscosity. We can study this coefficient of viscosity for various liquids or the lubricants. So now this coefficient of viscosity, which we are going to study, has got the unit. So what is the unit of this coefficient of viscosity that we have to see? Now the coefficient has got the unit. So coefficient mu, which we have written here as mu is equal to shear stress tau divided by du divided by dy. So this tau is nothing but shear stress, but we say here it as shear stress, and this du by dv is nothing but du is change in velocity. It is change in velocity or change of velocity, and dy is nothing but change of distance. Change of distance. Now always we know stress is nothing but force divided by area. Force per unit area. Force per unit area is stress. Whereas change in velocity is nothing but change in distance per unit time. So change or the distance covered per unit time, we can call this as length per unit time. Length per unit time. Then this change in the distance is nothing but length. So into 1 divided by length. 1 divided by length. So now we can see here this length and length gets cancelled. So in numerator, what is going to be there? Force. Force divided by area. So this time which is in the denominator of denominator comes into the numerator as time. So this area means, say for example, it is a rectangle. So rectangle has got area L into B. L into B. So what is L? L is also length and B is also length. It is a distance. L is a distance, B is also distance. So therefore we can write this as force divided by length or distance square. Area is nothing but length square or L into B. So unit of this is meter square. Meter is the unit of length. So length square into time. Now in SI unit, it has got unit of this is force unit is Newton, time unit is second, and length unit is meter square. Newton second per meter square is the unit for this viscosity or coefficient of viscosity. So in MKS unit, so this is in SI unit. In MKS unit, it has got the unit as force unit is kg force into second divided by meter square. So very popular unit for this is poise. So generally this mu is measured in poise. What is this poise? Poise is nothing but 1 poise is equal to 1 by 10 times Newton second per meter square. So 1 poise is nothing but 1/10 of Newton second per meter square. That is the relation of poise with SI unit. So this poise is nothing but that is 1 kgf second per meter square is equal to 98.1 poise. This is given in what you say in MKS unit. So 1 kgf second per meter square is nothing but 98.1 poise. So generally one thing we must remember, the coefficient of viscosity mu is measured in the SI units as Newton second per meter square, and 1 poise is equal to 1 by 10 Newton second per meter square, or Newton second per meter square is equal to 10 poise. So 1 Newton second per meter square is equal to 10 poise. So this, if you remember, so that will help us to solve the numericals. Then what is kinematic viscosity? So kinematic viscosity is defined as the ratio between dynamic viscosity and density of a fluid. So it is defined as the ratio of dynamic viscosity to density. So kinematic viscosity is represented by nu. So the term nu is defined as dynamic viscosity of fluid to the mass density of fluid or density of fluid. So this is kinematic viscosity. Kinematic viscosity is equal to dynamic viscosity divided by mass density. So mu is equal to mu divided by rho. So the unit of this is nu is the unit for this is, we see here, nu is equal to force time per meter square. So for this mu, what we had the unit as force into time divided by length square into 1 divided by density is nothing but kg. Kg means mass divided by length cube. So this is cube, this is square. So what happens here? This cube gets cancelled with this square. So what is going to what we are going to have? Mass divided by length. So mass divided by length, if we rewrite this again as this mass, we can take here multiplying this, just a minute. So what is there in denominator? Length. So we rewrite this force into time divided by mass divided by length in the denominator. So this we can rewrite as force is equal to mass into acceleration due to gravity. Force is equal to mass into acceleration due to gravity. So this force is nothing but mass into acceleration due to gravity. So here we write this force is equal to mass into acceleration due to gravity. So this is written as mass again. Acceleration due to gravity is length divided by time square. What is unit for this acceleration? Meter per second square. So therefore we can rewrite this as mass into length divided by time. Force is written as mass into acceleration, and this force is replaced by mass into length divided by time square. Mass into length divided by time square into time. So this force is replaced by this term. Then time is as it is, and whole divided by, we can write here again, mass divided by length. So if we see this mass gets cancelled, then length, if we transfer this length in the numerator, it will be length square. This time and this square gets cancelled. So what is going to be there? This length comes into the numerator. So length square divided by, only time is going to be there. Length square divided by time. So length is nothing but generally in SI system meter square divided by second. So meter square per second is the unit for this, what you call kinematic viscosity. So kinematic viscosity is given by meter square per second. So the standard unit, generally this kinematic viscosity is given in the units known as stroke. So this stroke is nothing but one stroke is equal to 10 to the power of minus 4 meter square second. So one stroke is nothing but centimeter square per second. Centimeter square per second. This is defined in CGS. Centimeter square per second is equal to one stroke, and one stroke is equal to 10 to the power of minus 4 meter square per second. So now this is about kinematic viscosity. Then Newton's law of viscosity, if we see Newton's law of viscosity, how we define this Newton's law? It states that the shear stress on a fluid element layer is directly proportional to the rate of shear strain. So shear stress is directly proportional to the shear strain. So just we have seen shear stress is proportional to the shear strain, that is du by dy. So tau is equal to mu du by dy, which we have defined as the viscosity. So this tau is nothing but the shear stress between the two layers. So when one layer is flowing over the other layer, so in between these two there exists a shear stress, and that shear stress is directly proportional to the velocity and inversely proportional to the change in the distance. So as we move away from this distance, so if this distance is going to increase, then shear stress is going to decrease. If this velocity is going to increase, shear stress is also going to increase. So mu is the coefficient of what you say dynamic viscosity. So this is nothing but the Newton's law of viscosity. Then this Newton's law of viscosity is helpful for us to know the Newtonian and non-Newtonian fluids. So if a fluid which obeys this Newton's law of viscosity, such fluid is known as a Newtonian fluid, which is known as Newtonian fluid. The fluid which obeys this Newton's law of viscosity is known as a Newtonian fluid, and if it does not obey, then we call it as a non-Newtonian fluid. So here we stop in this first lecture. In next lecture we will discuss about the remaining things. Okay, thank you.